Okay, perfect. Hello everyone here and on Zoom. My name is Rishi Vanukuru. I'm a PhD student at the University of Colorado in Boulder, and I'm here today to talk to you about our project DualStream. Now, as the title suggests, our main contribution here today is the design and development of a system for spatial remote communication using mobile augmented reality. We've demonstrated the potential of this system through scenarios and a short formative evaluation. But before diving into all of that detail, let's break down that first statement a little bit more. Now, human interaction and human communication is fundamentally tied to our ability to perceive and interact with each other in space. This is something that all of us are very well aware of, at least those of us who are here in Sydney. And when it comes to doing this remotely, there are systems like Microsoft's holoportation or Google's Project Starline that are able to replicate in-person interactions to quite a large extent. One key challenge with all of these systems is that they haven't been able to reach wider availability and application for a number of reasons. So most of these systems require multiple depth cameras that are expensive and tethered to specific physical locations. We still need standardized and efficient mechanisms for streaming volumetric information. And while they do use AR and VR headsets and while they're becoming more and more available, not everyone has access to these devices. And while we may not own a headset for personal use, all of us do have one of these, a mobile device. And the core idea behind our project and DualStream is to explore how we could use mobile augmented reality to develop systems for spatial communication that are much more widely accessible. So whenever we do use a mobile device, we always have one camera pointed right at our face and one or more cameras, in fact, pointed at our surroundings. So, and more recent phones like the iPhone actually have depth sensors both in the front and the back of the camera. So what we wanted to explore through this project was what if we could use the front camera to capture information about ourselves, use the rear camera to capture information about our surroundings, put that together with the phone's ability to track its position and display content in AR, and then develop a system for spatial remote communication using all of these features. Now, phones today can't quite do all of this on device. So what we did instead was we strapped an external depth camera pointed at our face that's connected to the phone directly to prototype interactions that are likely to be available in the near future. Our paper talks about a number of scenarios that the unique configuration of DualStream enables. But to give you a glimpse of what the application can do, I'm going to walk you through how it helps support truly remote assistance. Now, imagine a scenario where Torin here is out on the road and his car is broken down and he doesn't know what to do. And for some reason, of all the people in the world, he calls me, and I'm at home, and he wants to know how we can both end up fixing the engine. In using DualStream, what he does is he opens up the application and starts sharing the video of the boot of the car, the engine of the car rather, and asks if I can spot anything out of place. Now, if this was a normal mobile video call, I would see this video just plastered onto my own mobile video, my mobile display. But with DualStream, what happens instead is that I see a 3D representation of the car and its engine being streamed into my living room that I can view in AR and walk around. This is inherently spatial information that I can now interact with as if it was in my own space. Similarly, if this was a normal video call, Torin would see me as a small rectangle on the screen of the phone, but instead, he now can see me as a moving representation that looks like me and conveys my gestures as if I was right there by the roadside to help him. He can take a snapshot of the car that then persists in my local space, and I can point at that snapshot, which turns into a laser pointer in his world, where I can say, hey, maybe this is where the problem is, and you should try fixing that. And I also see Torin as if he's in my living room, walking around the car and asking for help. So I hope this helps reinforce the idea of what systems like DualStream are capable of doing. Mobile devices in this configuration enable us to interact with remote collaborators, with representations that look and move the way we do in real life. And by being able to share information about our surroundings with each other, we can both simultaneously be there with them and have them be here with us. A quick overview of some of the features of the application. What you see here is a screenshot from the UI, where you see a 3D hologram of Torin floating around. From this, I hope you get a sense that we're able to transmit and reconstruct facial representations to a reasonable level of fidelity. though the GIFs before this showed fairly flat representations, which I'll talk about, because we can, in the system, share information about self and surroundings, both in 2 dimensions and in 3 dimensions. So either as video feeds or as point cloud-ish representations that move in space based on the movement of the phone. As I mentioned, it's also possible to take snapshots of the environment to create a persistent shared space across 2 locations. Finally, we leverage the familiarity of mobile devices and allow users to seamlessly switch between a spatial AR call and a normal mobile video call, depending on the context at hand. And because we're using mobile devices, this scales very easily to groups of multiple people, as you see over here in the example of a group conference call around a table. So how does all of this work? As I mentioned earlier, we have an external Intel RealSense camera connected to the phone directly via USB, and that captures information about our face. We use the AR Core Depth API on Android devices to capture information about our surroundings. And this is an application built for Android devices using Unity. So we have information about depth and color from both the front and the rear cameras. The depth buffer is converted into a depth image where each pixel, the color of each pixel represents the depth at that point. We then compress all of those 4 different video streams into one single frame and stream that single video stream over the network. And on the other end, it's possible to then receive this video, extract all of the information, also receive the position and interactions from the phone, and then put that together and reconstruct these moving representations of self and surroundings. So, as we talked about earlier, a lot of the challenges that current systems for remote communication face are addressed by DualStream in different ways. You would have noticed that we've used specific cloud networking servers to make this application work, and one reason for that was because we wanted to be able to test DualStream outside of lab conditions and in real-world contexts. So we did a very quick formative study where we had participants both in the lab and outside in different states, countries, use DualStream and interact with the features with us while we were in the lab. The paper contains a lot more detail about the procedure of the formative study and our findings, but I'll just highlight 2 interesting insights. While we expected that users would normally prefer 3-dimensional information and 3D representations of faces and surroundings, we found that in a lot of cases, they did actually prefer 2-dimensional views and video feeds, but the fact that these video feeds were moving in their own environments added a great deal of mutual interaction to the experience. Furthermore, we also noticed that they preferred the idea of interacting with snapshots more than the live video feed. While this might be because in the current prototype, the resolution of the video feed isn't that great, the snapshots acted as anchors for conversation, and participants wanted to know if they could interact with these in very different ways by potentially moving them around, scaling them, and rearranging them to fit their local environment a bit better. As limitations and next steps go, there's obvious things that we can do in terms of improving the resolution of our representations and improving the interactions of the overall application. We're looking at using more modern devices, better rendering techniques, but if any of you have ideas on how we can get better at this, I'd love to talk to you about that. And of course, this was an initial exploration of features, but it's important for us to understand what contexts are probably going to be most benefited by tools like DualStream, and then run more focused user studies to understand real-world use in those contexts. Speaking of context, we don't imagine that mobile AR will replace video calls or immersive communication in virtual worlds. But what we're interested in exploring right now is the idea of mobile AR as a bridge between these different modalities and realities. Because as things stand, we have a sort of divide between tools that are widely available, like computers and phones, but they're not very immersive or spatial. And on the other end, we have very immersive and spatial tools that are based on AR and VR headsets, but aren't widely accessible. And mobile AR, we believe, kind of bridges this gap by offering wider availability as well as spatial interactions. So imagine for a moment, what if Mozilla Hubs had a mobile AR version where you could use an app like DualStream to stream your real self into the virtual world and interact with things more spatially? Or what if applications like Tilt Brush, where you're modeling things in 3D, enabled people to use mobile AR to be outside, join a collaborative design session, and stream real-world assets in real time into the 3D design space? As you can see, these are things that we are sort of working on, and if you have any ideas or would like to collaborate, I'm happy to talk more. So our hope here is that by showcasing applications like DualStream, we can motivate people to maximize the potential of mobile computing, mobile spatial computing in particular, and then look at how mobile devices can act as a bridge between the desktop and screen-based computing paradigm of the near future and spatial computing in the immediate future. Yeah. But as a quick summary and recap, we've developed a system for remote spatial communication using mobile AR. And some thoughts for you are, how do you think you would use something like this in your daily lives? And what do you envision mobile AR as a bridge for ecosystems for cross-reality collaboration? Before I end, I'd just like to thank the team. Turan and Sweeby are over here. Amy is probably online. But I'd also wanted to mention Kritik, Mark, and my advisor, Ellen. I'd like to thank the team at Ericsson Research, the participants of our study, and all the members of the ACME lab. You can find the paper, these slides, and a bunch of more videos at my website and using this QR code. But with that's it for today. That's DualStream. Thank you so much for listening, and I look forward to interacting with all of you now and through the conference. Thank you.